recording yet. So yeah, our test is going to be on the 26th, which is Tuesday. Again, we'll review today and then also Monday. We'll go through the different sections that were covered this chapter. There won't be a ton of proofs on our test, but there will be at least one or two. And hopefully you guys are feeling more confident about those than you were a few days ago. Is about the angles of a triangle adding up to 180. So we call that triangle angle sum. Put your phone away, please. Oops. And we learned that they always equal 180. That was when we cut all our little triangles out and we pulled their angles off the edge and we saw that they make a straight line together.
That was traumatic.
It was traumatic when we had to kill your little triangle.
Yeah.
All right. We also, there was two rules in this chapter, or this section. So we figured out that angles of a triangle add to 180, but also we learned about those exterior angles. So this angle is given by angle 1 and 2 together. So that was that exterior angle rule we had learned. We talked about classifying triangles, so like talking about words like acute, equiangular, obtuse, right, like equilateral, the isosceles and scalene, being comfortable with all those different classifications for triangles. We'll go over some of those vocab words more on Monday, just like the review words, but this is just a quick little sampling of questions that we could have. So if you guys take a minute to classify these as acute, equiangular, obtuse, or right, if you're also able to, let's actually add in a couple more vocab words. So if you can also classify it using words like isosceles, equilateral, and scalene if you're able to. Those are a few other words we have for those. So for each of these, let's put down two different words. So classify it based off the angles and then also off the side lengths. We'll see classifying those triangles by the angle and the side lengths. Triangle ABD. ABD is the triangle on the left side of this drawing. ABD. Someone give me a name for it. What do you guys know about it, Clayton?
It's acute.
It's acute. Oh, actually, I bet you could actually have a few more. So it's an acute triangle. It's also equilateral because all the sides are the same. Actually, we can have a third name for this one. What's that?
Equiangular.
Yeah, it's also all equal angles. If it's equilateral, it's going to automatically be equiangular. Those two always go together. So, like, these two are always a pair. I have some up there, sorry. But acute is a good description because all the angles we know would be 60, so they would all be acute angles as well. All right, so triangle ABC, which is actually the big triangle here. Sometimes trying to figure out which one they're talking about is part of the tough piece of this. So this big triangle here. What do you guys know about that one? Hey, Mackenzie? It's right. There's a right angle in the corner, and depending if you marked on it at all, if you can see that, there is a right angle in the corner. So that's the type of angle or triangle it is based off its angles. There's another name for it. This one might be a little bit tricky. Yeah, what do you think, Nick? It is scaling. There's actually no equal sides as far as we can tell. They tell us that this one is 1 tick mark, this one's 2, so we know those are different. And then they don't tell us anything about that one, so we would assume that all the sides are different. So scalene means all the sides are different. And again, probably most triangles would fall into this category in like everyday life if I was just picking sides of a triangle to form together. However, it's an easy one to forget about because we talk about the really special ones. All right, and then BDC is our last one up here. So that's here. Yeah, go ahead, Clayton.
It's obtuse.
Obtuse. And we'll talk about in a second why we know that. Mackenzie, what's the other word about it? It's isosceles. We have 2 equal sides. Now, question is, how do I know for sure it's obtuse other than it just looks obtuse? All right, go ahead, Clayton.
Those 2 other angles, if it was obtuse, they would have to be less than.
So those ones would have to be less than 90. That's important. Those have to be acute. But how do I know there's for sure an obtuse angle in this drawing? Because I do know this. Like, I know for sure there's an obtuse angle. Do you guys see it? Other than it just looks that way. Mackenzie? Yeah. And there's probably even a little, like, pages that you're going to say 2. Do you have a little bit extra you can tell us?
I was just going to say equilateral.
Yeah, it's equilateral, so we know what this one's angles.
It's all cute.
They're all acute, but they're all what?
60.
60. If these are all 60, what do I know about the angle right next to it? It's 120. So without too much work, we can figure out that's for sure obtuse, other than just kind of eyeballing it and say, hey, that makes sense. The acute thing, though, is a good one, too. The fact that this one is acute, if they form a straight line, the other one's going to have to be obtuse. So there's kind of a lot of things telling us this for sure has to be an obtuse angle. I would just tell you to be careful about just the visual part of it. Just saying, like, it looks obtuse, so I'm sure it is. So making sure that you're not just only going off of what it looks like, because there's times my drawings might be horrible or that I flipped something and put it in the wrong spot. I think I did that in the last test. You guys figured out an angle and it was supposed to be obtuse and it was actually acute when you figured it out. So my drawing was really bad, but just realizing that it doesn't matter if that's what they're telling us it is. All right, so the next one asks us to find all these different angles in this drawing. And this one kind of takes these 2 rules together. So the fact that we know the angles add up to 180 and then also that exterior angle rule. So hopefully you're able to find some of these different angles. So we want to find angles 1, 2, 3, and 4. I'll give you guys a minute if you haven't done so already. Try to find those angles. All right, guys, what angles do you know? Which ones jump out at you that you guys know how to find? Anybody else want to help us here? Yeah, go ahead, Lucas.
You can find number 3 by taking away 62 from 125.
Yeah, that's that exterior angle rule. So that's an easy one to miss, but it's a nice one when you notice it. That angle 3 and 62 together should add to 125. So he said do 125 minus 62, and that will give us angle 3, which is 63, right? Okay. All right. Somebody else help us out. Yeah, Mackenzie, or go Reagan. Sorry, I'll come back to you when I need you.
I found angle 63 plus the 62 and then whatever, I don't remember exactly what I got, and then I subtracted that from the 180.
Yeah, so that's one way to do it. So she used this triangle that I know those add up to 180. But you could also use this too, right? That adds to 180 as well. So either way should give you the same outcome. I kind of think this is interesting. You're like, oh, I did it a different way, but it works. So I mean, it doesn't matter how you got there, as long as you get around somehow. Right? So does that work out? Is that 55 here? Yeah. So that's angle 1. So angle 1 is 55. Aaron, do you have a different one for us?
Angle 4.
Angle 4. How'd you know angle 4? Vertical angles. Vertical angles should be one of your major go-to. Like, don't forget you know about vertical angles. So we have 4 and 120 or 125. Yeah, and angle 4 is that vertical angles there. Yeah, what do you think, Nathaniel?
Number 2 is 23.
Yeah. So then, and you got that how?
So I added 32 and 125, and I did 180 minus 117. Actually, 17.
I don't know. Check the math. Someone. Yeah.
It wasn't 117. I know that.
I got 125. Yes, you could.
For
No, sorry, for a change. I got 23.
I was like,
23.
we need to talk, kiddo. Like.
Okay, what I meant was 157.
Oh, okay, so you got 157 when you added those two. Yeah. Yeah. Yeah.
So what I did was I took 4 and 35 and I added 32 and subtracted that from 182.
Yes, I think that's what both of you were trying to tell us. Yeah.
I did it in the one that I put when I used this switch them and I knew that 35 was 32.
Oh, yeah. So I didn't even notice that one. So she actually looked at the exterior angle one here. Let me show you this. So she knew this was 55 and this was 32. And we're looking for this angle. So those two are that go with that exterior angle. Nice. No, and I like, for whatever reason, this what you notice first. I'm not saying one's faster than the other, like, or saying like, you know, Reagan's way wasn't the best way because I mentioned something else. It's whatever you notice first, because all of them are going to get us to that same answer. So what does that end up being? 23? Did we decide? 23. Okay. So that's kind of a unique thing about this, that we can get a lot of different ways to that same answer. All right, let's look at section 4.2. So in section 4.2 is when we talked about congruent triangles and other figures that are congruent, so all their parts have to be congruent as well. We ended up using this a lot throughout the whole chapter, so hopefully it was an okay, it's going to be an easy one to review. So congruent triangles and shapes. And basically this is where we learned that, you know, if they're congruent, they're 100% identical, so all the angles that match up, and the name is trying to help us with that. So like in this drawing, these are kind of ambiguous triangles. Like I can't quite tell what should be equal, just looking really quickly. I mean, maybe you have an idea, but the name helps us. So the fact that R and X are in the same position, that's telling me R and X should be equal. So that gives me that information. Now this one's kind of I don't love this question. I'll tell you guys on a test, I won't give you one that's quite this straightforward, because there's only two angles to set equal, there's only two sides to set equal. On a test, I might give you more information than you need. So I might label a few other things that you're like, why'd she tell us that if I'm not using it? So just be careful that sometimes I'll tell you guys more information just so you know not just to set things equal. Yep.
Can I start with it?
Yeah. Yeah,
Okay,
what you do?
so, I don't know if this is correct, but the two x variable equations,
Mm-hmm.
those I think are in the same line.
Yes.
Or the equivalent line anyway, so I just made them equal each other and solve that.
Yeah, and again, the way to check this is RT, we're assuming it equals ZX, and that makes sense because RT are the first and last letters. Z and X are also the first and last,
I
yeah.
just went through the thing we just learned that the triangles are equal all over the line.
Yeah, that's exactly it. And we just hadn't ever like written it out that clearly. We hadn't had like an acronym for it, that's CPCTC. That's essentially what we're using here, we just aren't explaining that. If they're congruent triangles, all their parts have to be the
Yeah,
same.
I'm never gonna remember that.
No, you don't need to,
I
it's okay.
Remember what it means.
Right. And you don't need to know the acronym, like it's not like you're not gonna be okay on the test without it. It'll be fine. So I believe X ends up being 35. And then we're gonna do the same thing with the Y's. Those angles match up like I mentioned before. But again, just be careful on the test that I'm not always gonna only have those two things marked. I might have a few other angles marked for you to kind of like distractors, so that you don't just set everything equal that you know. But these two angles should be equal. And hopefully pretty easy equations to solve here. There's not gonna be anything like that number 22 from our homework last night with the square roots. So Y ends up being 15. Alright. The next section was when we got into, or the sections, I actually have 4.3, 4.4, and 4.5 all together. The reason for that, I have a hard time separating them just because I think it's good for us to talk about how do we know all these different triangles are equal and all their different reasons we know that. So again, what we learned in these sections was this is all our different acronyms here. Now you have to be comfortable with which ones work and which ones don't. So these are the ones that work. If you need to remind yourself of the ones that don't, I think those are it. So these are all no-nos. So those ones don't work. We don't want to use those at all. If you end up using those acronyms, that means that the triangles probably aren't necessarily congruent. So the next 4 questions are basically just asking us to use the property. So yes or no, are they congruent? And then which of these rules can be used for them? So take a minute to look at 13 through 16 here. Yes or no, and then if it's yes, you have to be able to say what rule you used.